Hey everyone, and welcome to The Explainer. I am absolutely thrilled to have you with us today. If you're the kind of learner who loves taking complex, everyday technologies and breaking them down into clear, bite-sized insights, well, you're in the exact right place. Today, we are tackling a concept that is literally everywhere, yet for a lot of people, it still feels totally abstract and invisible. We're talking about cloud computing. We are going to decode the cloud, look right under the hood of the infrastructure that runs our digital lives, and make this incredibly powerful technology completely understandable. Let's get into it.
So let's think about your routine just this morning. Did you happen to check your email? Maybe you collaborated on a Google Doc, fired off a message on WhatsApp, or jumped onto a Zoom meeting. You might even be using Microsoft 365 right at this very moment. If you did literally any of those things, guess what? You're already an active cloud user. You see, the cloud isn't just some vague tech buzzword thrown around in boardrooms. It is the fundamental baseline infrastructure of the modern digital world. But when we strip away the slick interfaces of all these apps we love, what actually is the cloud?
Okay, here's our roadmap for today. We'll be hitting 1. Demystifying the cloud. 2. The 4 core pillars. 3. Cloud deployment models. 4. 3 cloud service models. 5. The 5-layer architecture. And 6. The big cloud players. Let's jump right into Section 1, Demystifying the cloud.
Here is the formal textbook definition we need to anchor ourselves to. Cloud computing is the on-demand delivery of compute power, databases, storage, and applications via the internet, featuring pay-as-you-go pricing. But honestly, let's use an analogy to make this really stick. Think about electricity in your house. When you need to turn on a lamp, you don't go out into your backyard and build a power plant, right? You just flip a switch, tap into a massive shared grid, and pay the utility company only for the exact amount of electricity you actually used. Well, cloud computing works exactly the same way, just for IT resources. It gives organizations the ultimate flexibility to tap into high-end infrastructure without the massive crushing upfront costs of buying and maintaining their own physical servers. Now, to really appreciate where we are today, we have to look at how we got here. Back in the 1960s, it was all about massive mainframe computing. Then, by the 1980s, the technology shrank down to personal computers sitting right on our desks. In the 1990s, we started connecting those machines through client-server computing, which eventually exploded into the massive expansion of the web in the 2000s. And that brings us right to the present day, cloud computing. We've fundamentally shifted from thinking of computing as a physical product you have to own to computing as a flexible, on-demand service you just access over the internet.
Moving right along to Section 2, the 4 core pillars.
Our first core pillar is scalability. Scalability is simply the ability to adjust your computing resources up or down based on your exact real-time demand. There are essentially 2 main ways to pull this off. First, you have vertical scalability. This is kind of like upgrading your existing computer. You're just adding more CPU, more RAM, or more storage to a single server to make it much beefier. Then on the flip side, there's horizontal scalability. This is about adding more servers to share the workload, literally expanding your computing power outward. This is absolutely crucial because it ensures a business can efficiently handle massive spikes in web traffic without having to invest in permanent, expensive hardware that they just won't need a week later.
Our second pillar is elasticity. Now, I know what you're thinking. That sounds exactly like scalability. But there's a really vital difference here. Elasticity is all about the dynamic, real-time allocation and deallocation of resources. Imagine your server capacity rising and falling automatically in direct response to fluctuating demand over time. As the workload spikes, new resources are provisioned on the fly. And the second that demand drops, those excess resources are instantly released. This is the real magic of the cloud. It ensures you're perfectly optimizing your resource utilization, meaning you are never overpaying when traffic is low.
That brings us to our final 2 pillars, reliability and security. For reliability, cloud providers don't just put all your data in one place. That would be a disaster waiting to happen. Instead, they operate distributed infrastructure. We're talking multiple data centers spread across different geographic locations. So if one server fails, or even if an entire data center goes completely offline due to a storm, redundant systems instantly take over to prevent any data loss. And as for security, these providers deploy absolute military-grade protections. They use encryption for data in transit and at rest, advanced identity management, and they undergo super strict compliance audits. Honestly, they usually secure data far better than a traditional in-house IT department ever could.
All right, Section 3, cloud deployment models.
So where does your cloud actually live? Well, deployment models define the specific type of access an organization has to the cloud infrastructure. And there are 4 primary flavors here: public, private, hybrid, and community. Let's put the 2 heavyweights head-to-head first, public versus private. A public cloud means the infrastructure is hosted by a third-party provider and the resources are shared among multiple different organizations. It's incredibly cost-effective and highly scalable, but because it's an open, shared environment, you do get a bit less customization. A private cloud, on the other hand, dedicates all of its resources and hardware to one single organization. It can be hosted on-site or by a third party, and it offers absolutely unmatched security and control. That makes it the go-to for companies dealing with highly sensitive data. However, as you might guess, that kind of exclusivity comes with a much higher price tag. The other two models are more specialized solutions. A hybrid cloud is, well, exactly what it sounds like, a customized mix of public and private. This lets an organization keep their highly sensitive, mission-critical data locked down on a secure private cloud, while simultaneously using the much cheaper public cloud for everyday, non-critical operations. Finally, we have the community cloud. This is an infrastructure shared by several specific organizations that have common goals, similar strict compliance requirements, or maybe they just belong to the same industry. It's a clever way to split the costs while still maintaining a much higher level of security than a standard public cloud.
Next up, Section 4, 3 Cloud Service Models.
Okay, so we know where the cloud lives, but how is it delivered? The crucial point here is understanding exactly who manages what. These 3 models dictate your level of control. At the base level, we have IaaS, or Infrastructure as a Service. This provides the raw, virtualized building blocks, the servers, the storage, the networks. You manage the operating systems and the apps. The provider is just managing the hardware. Amazon EC2 is a great example of this. Step up one level and you hit PaaS, Platform as a Service. This gives developers a complete, ready-to-go environment to build and deploy applications without ever having to worry about the underlying servers. Think Heroku or Google App Engine. And finally, right at the top, we have SaaS, Software as a Service. This is fully functional software delivered directly to your web browser. You don't manage anything at all except your own data. Google Workspace and Salesforce are perfect, everyday examples of SaaS.
Now let's really peek under the hood. Section 5, the 5-layer architecture.
Let's build this from the absolute ground up. Because remember, the cloud isn't just magic, it's hardcore physical engineering. It all starts at the bottom with the fundamental layer. This is literally the raw electrical energy, the heavy-duty cooling systems, and the building engineering that keeps the machines from literally melting down. On top of that sits the hardware layer, the massive racks of physical servers, hard drives, and thousands of miles of network cables. Next up is the virtualization layer, which magically takes those physical machines and chops them up into flexible virtual resource pools. Right above that is the operational layer. This is where your operating systems, your databases, and your actual business logic live and breathe. And finally, capping the whole thing off, is the management layer, which carefully oversees backups, archiving, and the continuous control of everything operating below it.
When you stack it all together, this hierarchy forms a really fascinating structure. In fact, some of our source material even likens these layers to the levels of human thinking, starting from the raw manifestation of physical energy way down at the bottom, all the way up to the complex modeling and replication of reality up at the operational layer. It's a cool thought. But from a strictly functional standpoint, the most important takeaway for us is this. The sole purpose of the fundamental, hardware, virtualization, and management layers is entirely to ensure the continuous, safe, and robust working of that operational layer in the middle, because at the end of the day, that operational layer is where the actual computing work of the world gets done.
Almost at the finish line. Section 6, the big cloud players.
So, who actually owns and operates these massive architectures? While there are plenty of providers out there, a few absolute titans dominate the public cloud space, and they're the ones making enterprise-level computing accessible to everyone. First up is Amazon Web Services, or AWS. They are the massive pioneer in this space, offering a highly scalable, extremely robust suite of services ranging from database storage all the way to global content delivery. Then there's Microsoft Azure. Because Azure seamlessly integrates with Windows operating systems and existing Microsoft enterprise frameworks, it is a huge favorite for large corporations looking to simplify their migration to the cloud. And rounding out that top tier is the Google Cloud Platform, or GCP, which powers some of the most data-intensive, complex applications on the internet today.
To wrap up our explainer today, I want to leave you a kind of a wild thought. We started out by mapping the evolution of computing from those huge room-sized mainframes in the 60s to personal PCs, to the web, and now to the cloud. The cloud has entirely transformed computing into a utility, literally just like your water or your electricity. It's no longer a shiny new innovation, it is our fundamental baseline infrastructure. So if almost infinite computing power is now available to anyone, anywhere, at any time,
What does the next frontier of computing look like? How on earth are we going to build on top of this invisible global grid? Think about that the next time you casually open up a Google Doc or stream a video. Thank you so much for joining me on this explainer. Keep learning, stay curious, and I'll catch you in the next one.